now I would like to talk to you about what you would have done in lab if you were to do this experiment. The experimental portion of this lab was actually extremely short. Most of this lab is about writing precipitation reactions. So even though it's kind of cool to see the precipitate, you're really not missing out on any technique. So on the left, what you see are spot plates. The spot plates are just wells for conducting precipitation reactions so that you can see the precipitate that forms. We would have had two spot plates, a white spot plate and a black one. The reason we have two different colors is because some of our precipitates are white. White precipitates are really hard to see on a white background. So for example, the precipitate that is right here is pretty clearly seen in the black spot plate, but it's pretty hard to see in the white spot plate. However, some precipitates are colored. This one, it's a little hard to tell, but this is actually a yellow precipitate. So you want to look at it on the white spot plate so you could truly assess the color. Because if you look at it on the black spot plate, it starts to appear, like a greenish color. So in the lab, you would have started with bottles of aqueous salt solutions. The top solution is copper 2 sulfate. When it's dissolved in water, it's this beautiful blue color. However, most of our solutions wouldn't be so dramatic. For example, barium hydroxide, which is the bottom liquid, it pretty much just looks like water. So what you would have done is you would have taken 2 drops of one solution and say you would put this into well number 5, and then you would have taken 2 drops of barium hydroxide and put it into well number 5. And then you would just watch to see if a precipitate forms. And then you would have done the same in the black spot plate. Put 2 drops in well number 5 here and 2 more drops of the barium hydroxide, and you would just look to see if a precipitate formed. If a precipitate formed, you would just then describe it in your lab notebooks. Tell me what color it was, and does it look like it's fluffy or crystalline or powdery, something like that. So I'd just like to take a moment to look at the lab manual with you. So section 1, the introduction, I would like you to read this. Pay attention to anything that is a defined term. Table 2 are the general solubility rules, and we've talked about that in the introductory video. And what I have here is review 8.1, and it's just a few different quiz questions, or not quiz questions, but review questions to see if you do know how to use the solubility table. So I do recommend that you try those 4 questions, and the answers are down below. And then as far as the part of the lab that we're going to be doing, you would have done 2 parts of the lab. Part A would have been making these 8 different mixtures in the spot plates that I showed you. So we would have told you what the solutions are that you're mixing. You would have taken 2 drops out of each bottle and mixed them together in the spot plate. So we're going to be working with the solutions that are shown in this table to predict what the precipitate would be that would form, and then you're going to be writing the balanced molecular full ionic and net ionic equations for each of those 8 reactions. Part B of the lab, that would have been identifying a set of unknown solutions, and you're not going to be doing anything with that in this lab. So we're just going to be working with the mixtures that are shown here in part A. And then the calculations and discussion sections has something that I would like you to go over on your own. The video 8.1 is a 10-minute video on how to write balanced molecular, full ionic, and net ionic equations. And after you watch that video, then I'd like you to read this example on writing balanced molecular, full ionic, and net ionic equations. And then after you do watch the video and read my instruction, you'll go ahead and try these on your own for these mixtures shown in table 3. So what I have done is I've taken table 3 and I've actually rewritten it for you and loaded it onto Blackboard in a format that I think will be conducive to doing this lab asynchronously. Um, so if you go to Blackboard, and hopefully this is going to be similar to your view because I'm showing you instructor view right now because I haven't actually made this lab visible to you. So if you go into the Experiment 8 folder, there'll be something called a precipitation table. And if you click the 3 dots and you say export, and I would say bring it to Notability. So let's go see. We'll go to Notability here. And here is our precipitation table. And I've also copied a few things out of the lab manual to make it easy. I've copied the table of polyatomic ions and also the general solubility rules. Now, I am not requiring you to use my table. I am requiring you to complete all the information that is in this table, even though it's not specifically stated like this in the lab manual. Um, but if you look, I have all 8 mixtures written down. I have the reactants, which would have been the species you would have mixed together. Those would have been held in the bottles. And I have the phase. So if you look at the phase, all of these are listed as aqueous. And that's because what we would have had is sodium chloride dissolved in water, silver nitrate dissolved in water, barium nitrate would have been dissolved in water. If the salt is dissolved in water, it's considered an aqueous species. So if you look down the table, what you see is everything is listed as being in an aqueous phase because all of these salts would have been dissolved in water for you. So what I want you to do now is to figure out what's the cation and what's the anion in each of the reactants. So just so you understand how salts are always written, the positive species is always written first. So just remember, cations have the positive charge and anions have the negative charge. So for all of these salts, the first species written would be the cation. So sodium, silver, barium, sodium, silver, potassium, etc. The first species is always the cation. The second species is always the anion. So here the anion is chlorine, NO3, which is nitrate. The nitrate group is the anion. For the next one in mixture 2, barium nitrate, the nitrate group is the anion. For sodium sulfate, the sulfate group is the anion. In mixture 3, the nitrate group is the anion, and the iodine is the anion. What I want you to note, however, is something that is very, very confusing, is that I did not highlight this 2. When we're talking about sodium, if sodium sulfate dissolves into water, you actually get 2 sodiums and then you get a sulfate group. So this 2 right here, it just means there are 2 different sodium atoms floating around in water along with your SO4, which is their sulfate group, which has a 2 minus charge. So why is it that the 2 on the sodium, why is that not part of the sodium cation? So for instance, why is it not Na2? And it's not. But here with SO4, we have this 4 down below. So we keep the subscript on SO4, but we don't keep it with the sodium. The difference is that SO4 is considered a polyatomic ion, and the polyatomic ions are something that you'll just have to start to recognize. And so let's look at the table of polyatomic ions. So if you look at polyatomic ions, it's always an oxygen bonded to something. So if your subscript is on the O, then the subscript is going to stay there. However, if the subscript, and I'm going to change colors, if the subscript is on something like a chlorine or a sodium, let's look here. Here's another one on sodium. So you can see in those cases that I've highlighted, here's another one on Cl2. In those cases, those are not polyatomic ions. You don't have an oxygen bonded to something else. So when we have FeCl3 that dissolves into water, it's going to dissolve as an Fe3 plus cation plus 3 separate chlorine anions. So let's try to figure out for mixture 2 what the cation and what the anion are for each of the two salts that we start with. So for barium, barium is Ba with a 2 plus. It has a plus 2 charge on it. The reason we know it has a plus 2 charge is because it is in column 2 of the periodic table. Anything in column 1 has a plus 1 charge. Anything in column 2 will have a plus 2 charge. Now the nitrate, the polyatomic ion is just NO3 minus. And if you look down here at the polyatomic ion table, you see we have the charge shown on the NO3 group. So the nitrate group always has a -1 charge. If you look here, and I forgot to highlight this, there are 2 NO3 minus charges. The reason is the charges have to balance. So if you have 2 positive charges, you have to have 2 negative charges. So since barium has a +2 charge and each nitrate only has a -1 charge, you have to have 2 nitrates associated with every barium. So right now, I don't really care, and it's not really important for you to necessarily know that there's 2 nitrates here. We just want to know the identity. What's the identity of the ion? So it would be best if you just would write down the identity of the cation and the identity of the anion, but not necessarily how many of each one you have. So let's do the same thing for the sodium sulfate. So the identity of the sodium ion is Na plus. Yes, there are 2 of them. That doesn't really matter at this point. I know that sodium has a +1 charge because it is in column 1 of the periodic table. Sulfate, let's look at the polyatomic ion table. Sulfate is shown right here. It has a 2- charge. So it's SO4 and it has a 2- charge. So it makes sense that there would be 2 sodiums because since sulfate has a 2- charge, we have to have as many positive charges as negative charges. Therefore, we need 2 sodiums. That's where the subscript 2 comes in on the sodium. So I'll just do one more example. Let's look at FeCl3 in mixture 4. So iron, we know the identity of the cation is Fe, iron. We don't know the charge on it. If you look at the periodic table, it's in the middle of the periodic table, so you can't just tell what the charge is by looking at its location. Chlorine, however, is in column 7 of the periodic table, and everything in column 7 has a negative charge, a -1 charge. So what we know is that we have 3 chlorines, and each one carries a -1 charge. So if there's 3 -1 charges, there has to be 3 positive charges. So therefore, we know that iron has a +3 charge. So now let's talk about our 2 possible products that can form. Once we mix all of these 4 ions together in the spot plate, all of a sudden, the sodium cation has access to the nitrate anion, and the barium cation has access to the sulfate anion. So our 2 products that we could form would be now sodium nitrate and barium sulfate. Now notice when you're combining cations and anions together, what's important is that you charge balance. So with the sodium and the nitrate, the sodium has a +1 charge and the nitrate has a -1 charge. So they charge balance. So you just need 1 sodium with 1 nitrate. Likewise with the barium sulfate, the barium has a +2 charge and the sulfate has a -2 charge. So again, they charge balance. So you need 1 barium with 1 sulfate. So something a little more complicated would be to look at mixture 4, where you have sodium, which has a +1 charge, and the hydroxide group, which has a -1 charge. And so now if you're combining the cation and anion pairs, the iron with the hydroxide or the sodium with the chloride, well, it's pretty straightforward to do the sodium with the chlorine because those two charge balance. The iron with the hydroxide is more difficult. The iron has the +3 charge and the hydroxide group has the -1 charge. So therefore, for every iron, you will need to have 3 hydroxide groups, and you put that as a subscript when you need to have multiple groups or multiple of that ion in the ionic species. So for mixture 2 here, we just have 2 more columns to fill out, the phase and then the image that I want you to get. So for the phase, what you do is you look at the solubility table. So the first one, sodium nitrate, that one's easy. Anytime you have a nitrate, anything attached to a nitrate at all nitrates are soluble in water. They never ever form precipitates. So for sodium nitrate, we know that this phase is AQ for aqueous. It will stay dissolved in water. For barium sulfate, let's go look at the solubility table again and look here and we see, okay, sulfates. Sulfates are usually soluble in water, but there are some exceptions. One of those exceptions to the rule is barium sulfate. So that means that barium sulfate will precipitate in water, or in other words, it will form a solid. So you give it the S subscript for the solid phase. And since you're not observing these precipitates in lab, I do want you to know what they're going to look like. So anything that is solid, anything that is a solid phase, I want you to look it up. So let's go, I would recommend just going to Wikipedia. And here we have barium sulfate. And so what I would like you to do is, let's see, we would download the file. And you're going to need to attribute the author in your lab report. So let's just go like this. Let's first just take a screenshot. So we'll take a screenshot. If we go here, we click on it, you can edit it, so you can crop it down. And then hit done. That will save to the photos. And so let's go into Notability here. We're going to use the plus button up top, photo library, add our one photo from the day, make it smaller, and we'll put it right over here in the image. So we have the image of barium sulfate, and now someplace in your lab report you have to have the attributions. So let's just go back here and go to more details, and let's see. Here's the attribution. So we would just copy this, bring this back to our lab report, and I'd say, just go onto another page, and I think if you hit the text button, you'll get a text box where you can just say paste. And what I would do then is just somehow to the side, just put down BASO4 image. So that's what I want you to do for every one of these 8 mixtures. I will give you a hint. For one of the mixtures, both phases will be aqueous. There will not be a solid species. And for one of these mixtures, you will have 2 solid species. For the other 6 mixtures, you will have 1 aqueous species and 1 solid species. So just to repeat, for each mixture, go ahead, figure out what the cation and what the anion is for each reactant, figure out what the products of the reaction would be, determine the phase of each species formed, and for every solid that you have, please find and paste an image. And I would recommend using Wikipedia just because those images are typically either free to use without attribution or free to use with an attribution. So after you fill out that table with all the products of the reaction, you can take it and you can email it to your instructor, your lab instructor, if you want somebody to check to make sure you have the answers right. And so after you do that, go outside, find somebody to play with, take a break, and come on back when you're ready to learn about writing precipitation reactions.
All right, Scout. You want to give me that ball? You want to give me that ball? I'll throw it. I'll throw it for you.